We'll proceed in summation and integral calculus. Summation and integral calculus. Okay, it is integral part of mathematics. Summation and integral calculus, which is integral part in mathematics, and it is integral part in mind-blowing technology that brings a normal solution, that can be thought as bringing normal solution to transferring the normal summation to integral calculus, where normal summation is not possible. Where normal summation is not possible. We have given one example. Consider summation of S. Summation is S. There is something called S. S equal to 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and so on till infinity. Can someone calculate this summation? At least I have found many solutions to this. Means there is no solution available there. Summation equal to 1 by n plus 1 by 2 plus 1 by 3. In last video we have talked about it. Okay, little bit we'll talk more on it before proceeding to another mind-blowing case study. Okay, so if I take case study for this, then this can be rewritten as summation sign sigma. Sigma sign I equal to 1 to n. Sigma I equal to 1 to n, and then 1 by I. That will be 1 by 1 plus 1 by 2 plus 1 by 3 or something like that. Okay, can it be transformed into integral calculus? Certainly it can be transformed into integral calculus. What is difference between these two? If I say I have a summation I equal to 1 to n, I have a summation I equal to 1 to n, 1 by I. Okay, this is typically a case of repeated summation. What is the typical case of integral calculus? Limit sign function over x dx. Okay, means integral calculus talks about multiplication of two items, fx and dx. That is multiplication. Or the area computed between x-axis and function over x-axis. If this is x-axis and this is y-axis, this is origin. This can be considered as function over x-axis. This is x-axis. Okay, if I draw a graph here and then that graph is function over x. What is function over x? At any point x, if I draw a vertical line, it will hit the graph. If there is a graph like this, okay, from any x, if I draw a vertical line, it will hit that graph. This height is called fx and this point is called x. At x, what is fx? Make sense? Okay, so if we are, okay, so now if I have height at any point x, if I go up, that is the, if height x is 2, I go up and hit the curve. That height is function over 2 and this is 2. Fx dx means if I take whole curve and underneath whatever the area that is hitting the x-axis, from x-axis, let's go like this and then see the curve, or from curve, if I come like this with x-axis underneath it, okay, if this is x-axis and this is the curve, the underneath this curve, what is the area that is fx dx? What is summation here? Summation I equal to 1 to n. Summation I equal to 1 to n. Okay, what we are talking? Summation I equal to 1 to n. This is what we are talking. Summation I equal to 1 to n. Okay, summation I equal to 1 to n and 1 by I. Okay, why I want in integral calculus? Because this is not solvable. No one can solve it where n tends to infinity. What is the net addition? Even though n is not tends to infinity, still solution is not available. Consider n is 100. Then what exactly the value will be? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 100. What will be its value? No one knows. Summation I equal to 1 to n, where n is 100, n is 200, n is 1000, 10,000, infinity. Because this summation converges, it goes minimum tends to 0. So it's possible to add it. It will not be infinity. Okay, what will be the solution? No one knows. Okay, can we try it converting into integral calculus so that we will get result in form of some algebra, and then setting the point of x from one point to another point, and we can calculate the result. This is what everyone wants. Okay, let's make it algebra. Summation I equal to 1 to n. Summation I equal to 1 to n, and then 1 by x. Summation I equal to 1 to n, 1 by x, where x belongs to ith section. Make sense? Okay, what I'm trying to say is, if this is x-axis, consider this is x-axis. This is x equal to 1, 2, 3, 4, 5, 6. Summation I equal to 1 to n, 1 by x, where x belongs to ith section. If I say this is a first section, second section, third section, for first section I is 1, x is 1, second section x is 2, x is 3, like this. So there are two things. We were talking about difference between summation and integral calculus. Integral calculus, if I have a curve, then integral calculus calculate the area underneath it. But this repeated summation just add all the vertical line. Okay, someone can say that, is it something like that, if I have a function, then function is sampled at some x point or whatever it is. If I have different vertical bars, at x equal to 1, I have a vertical bar. At x equal to 2, I have a vertical bar. As x equal to 3, I have a vertical bar. As x equal to 4, I have a vertical bar. Like this, I have vertical bar. If I add all the vertical bar, then this is what I want. That is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. These are the value that is drawn at different x point, and these are the value that has been taken from a function called 1 by x. There is a function called 1 by x, and values are taken at different value of x, where x is changing 1 by 1 at x equal to 1, 2, 3, 4. This is the problem. Okay, now solution is, no one can find the solution in very simple manner. Solution can we use integral calculus. Integral calculus, if I give a function, if I give a curve and I try to calculate the integral calculus, it will give the area underneath it. That's it. What integral calculus does, if you have a function, if I have a sinusoidal function, this is x-axis, this is origin. If this is sinusoidal function, this is sinusoidal function, and then come back again at 2 pi. This is pi. What is sine x dx? What is integration of sine x dx? Let's integrate it over. What is integrate it over? Integration means calculation of the area. Then if I calculate the area of sine x from 0 to 2 pi, 1 is below x-axis, 1 is above the x-axis. Then it should be 0. Try it. Who is stopping you? Try it. Sine x dx integration will come as minus cos x. Minus cos x is considered as the area algebra, area vector or area algebra. If sin x is the equation of a curve, then sin x dx, that becomes minus cos x. Minus cos x is called area. What I can say, it can be considered as area algebra, area equation. If sin x is the equation of a curve, then cos x is minus cos x is the equation of area. At any moment I take the value of x in minus cos x, it will give the area from 0. It is area algebra. It is not area vector, area algebra. What I mean is, if I say cos pi by 2, then it will give area of sin x from 0 to pi by 2. If I say cos, this is the area algebra, area vector, whatever. If I say cos pi, then if you give area from 0 to pi, let's see cos pi. What is cos pi? Cos pi is -1, and minus cos x is the area vector, area algebra, area equation. Then it will become 1. The area between sine curve of between 0 to pi is the 1. Okay, what about cos 2 pi? Cos 2 pi minus sin x dx is cos minus cos x, minus cos x from 0 from, I'm sorry, I'll repeat it again. So the integration of sin x is cos x. Cos x is called area vector, area algebra. Area algebra means whatever the value I keep in as x in cos x, it gives me the differential area. This is the better word. Differential area when x equal to 0. When x equal to 0 to whatever x I put. If I'm saying what is the area between when cos x is pi, cos x pi is -1. Cos 0 is 1. 1 minus 1, 2. Area is actually 2, not 1. From 0 to pi, sin x area is 2. What about cos 2 pi? Cos 2 pi, then cos 0 is 1 and cos 2 pi is again 1. 1 minus 1, 0. There is no area. The way, so cos, I can draw another algebra. If I draw the curve of cos at 0, it will be 1. This is the equation cos. But cos is also called area vector. Wherever it goes, value will give the area, differential area with the 0, or someone can take the limit. Okay, this is how it is. Anyway, now if I want to transform the repeated summation into integral calculus, mind it that integral calculus gives the area. Whatever the, if I do integral calculus of any algebraic equation, whatever comes out of it, integral, I'm not talking about the limit. Limit will give the begin limit to end limit. Okay, that is another thing. If I integrate a algebraic equation with dx, or if I then actually we are trying to calculate the area algebra equation, area equation. First is curve equation, and if I integrate, it will become area equation. If I have area equation, if I differentiate, it will become curve equation, opposite way. Okay, if I have area equation, if I differentiate, it becomes curve equation. What you are saying? I know the differentiation gives the rate of change. Rate of change of area is the curve only. Okay, if I have area equation, what is your area equation? Area equation is 2x. Means at x equal to 0, the area is 0. When x equal to 5, area is 10. X equal to 10, area is 20. This is area equation. If it is area equation, then what is the actual equation for which this is area equation? Okay, then you have to differentiate. 2. 2 is the actual equation. Means if this is x-axis, then there is a flat line called 2. Okay, what is the area of this underneath this flat line? If there is a flat line, if there is a flat line like this, then what is area underneath? This is the area I am talking. If there is a flat line, what is area underneath? Where from you want? I want from x equal to 0 to any x. Okay, then area will be 2 dx, 2x. Now 2x is like this. Can someone believe it? This is called area equation. This is the curve equation. Then this is area equation. This line is the area equation. It carries the value of area. If I x equal to 2, then the height is 4. 4 is area, not the height. 4 is area. When x equal to 0, height is 0. 4 minus 0. I'm not talking about inside area. What is inside area? If I want inside area, then what is 2x again integration? It will be, okay, x 2 integration is 2x. Integration of 2x will be x square by 2, x square. Then it will be this line. Can you see this amazing thing? Now this will be x square. Okay, this, what is this? Integration of area vector. So integration of a curve gives the area equation. integration of area equation someone can see. Probably it will give you volume equation. Full volume equation. If I have an if this curve is belongs to area, if this curve belongs to area, I multiply area with the base, it will become volume. So x square is a volume equation. If I differentiate volume, then it becomes area. Volume means at any moment what is the height. Volume means if I am trying to calculate the volume, if I am trying to calculate the volume, what is the volume at any what is the volume at any point x? Then that is the height. If this curve belongs to volume, what is the height? If this line belongs to area, then at any moment, what is the height? What is the height? This is the area. If this line belongs to a curve, then at any point, what is the height? That is the equation of the curve. Makes sense? Consider this is acceleration graph. This is acceleration graph. At any moment, what is the acceleration? A motorbike is driving. Okay. And then at what is his acceleration? Acceleration is 2. 2. Any unit. Acceleration is 2. The motorbike is driving and its acceleration is 2. Means he is accelerating. Okay. At 2 kilometer per second square, I believe, per hour square. 2 kilometer per hour square. Heat acceleration is, okay, anyone can understand whatever it is. Okay, distance is kilometer, then velocity is kilometer per hour, then acceleration is kilometer per hour square. 2 is acceleration, means he's accelerating more or less in rough manner. He's accelerating bike at 2 kilometer per hour square, and that is acceleration is constant, and this is a curve. What is the area underneath it? Then you have to integrate. If I integrate, this is the area underneath it. This is the line that talks about area. At any moment, what is the height? That is the area. So if I say 2, the area curve is 2x. Okay, if I integrate acceleration, it will become velocity. Means velocity is growing. Can you see? If acceleration is constant, then velocity is growing. And velocity is nothing but acceleration area with the x-axis, that is hour. X-axis is hour, and that is the acceleration. Okay. Now, if I talk about this, then this height is velocity. This height is velocity. Okay. Now at any moment, what is the velocity? Velocity is growing. If this is time, if this is time axis, our axis, I believe time or distance. Okay, I will say it. If I believe it is a kind of okay, I believe it is okay. Let's consider it is distance. At this beginning distance, the velocity is 0. At some distance, there if I calculate the height, this much is the velocity. Means if I take the distance by distance, then at that moment, if I calculate the speed of the bike, then bike speed is different because velocity is growing. Now, if I integrate this, if I calculate the area underneath it, it will become like this. Okay, so I believe I'll rephrase whatever I was saying. So this axis is time axis, not distance axis. This is time axis. Now at this moment, the person distance at a particular time, he is at the beginning position. At time is growing, he is how far he is. Now the vertical is saying how far he is from the beginning. So he is x square. Now it is x square, means it is his distance from the beginning is changing with the x square when time is growing. Okay, if I differentiate x square, it becomes 2x. Now if I take any moment, any time, what is his velocity? Then velocity is growing like this. If I do the differentiation again, it becomes curve like this. This is acceleration. At any moment you see acceleration is same. Okay, so these are called area equation, volume equation, curve equation. We are introducing curve equation, area equation, okay, volume equation. Okay, that is the fundamental. If I go with the integral calculus, then we try to calculate area equation. Whereas if I see the repeated summation, we are into curve fashion only, curve height. Okay, if I say what is your curve, the curve is 1 by x. Curve is 1 by x, where summation I equal to 1 to n, 1 by x. X belongs to a particular I. So I is 1, then 1 by 1. I is 2, then 1 by 2. I is 3, then 1 by 3. X belongs to of that particular I. This is summation, normal summation of some quantity. If I want to bring into integral calculus, then the quantity, then we will have a curve, and integration will calculate the area underneath this curve. Makes sense? If I want to convert in this fashion, then we have to see that we have to see that both should be same. If I say I have summation I equal to 1 to n fx, where fx is 1 by x, this is same as integration gx dx. This is same as integration gx dx, because I have to get gx, so that if I integrate with dx and put the limit, then it will come exactly same as what I was getting with the calculation. What I am saying is, if I equal to 1 to n, if I equal to 1 to n, I have fx, then I am trying to make 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by n. Whatever amount I am getting, if I am trying to solve for integral calculus, then I have one function called gx. Gx dx will give the area, and that area from begin limit to end limit. Begin limit right now it is 1. We have to start with the 1 only. Begin limit is 1 is 1 1. If I am taking as x, not necessarily I will go with the 1 only. I can change the coordinate system, then accordingly I have to map there. Right now both I am taking as x and y only. So begin will be 1, begin will be 1, and end will be n, and then gx dx. If I get another, right now I have a curve called 1 by x. 1 by x curve will come like this. Okay, it will come like this. 1 by x curve will come like this. At 1, this is 0. At 1, height is 1. At 2, height is 1 by 2. At 3, height is 1 by 3. Like that. I have to take another equation, some another equation called gx. This is fx. Summation I equal to 1 to n fx. This is what I want, where fx is 1 by x. X at any point I, in a gap of I. I want now integration x from 1 to n gx dx. In that fashion, what will be gx, that if I have some another curve, and if I calculate the area from x equal to 1 to x equal to n, the area underneath it, then that area will be same as what I am getting here with calculation of all the values of the 1 by x function. Okay, that should be same. If, okay, we have given different analogy. One analogy is that I have the curve, I have a curve summation summation I equal to 1 to n 1 by x I into 1. 1 by x is same as 1 by x into 1. Then I can rephrase as delta xi. 1 as delta xi. It becomes fx delta xi, where I equal to 1 to n. This is a fit case to convert into integral calculus. Fx dx, x is 1 to n. But what is stopping us directly converting into integral, where delta xi is 1? But to convert any repeated summation into integral calculus, what stops us is that delta x should be tends to 0. Delta xi tends to 0. It should not be tends to 1. It should be tends to 0. So that it does not fit. It is not the very fit case. What is fit case? Fit case is that we have to find another function gx, and something like summation k equal to 1 to n, summation k equal to 1 to k equal to 1 to whatsoever, summation k equal to 1 to whatsoever m, summation k equal to 1 to m. Okay, fx into delta x. fx at x equal to k delta x means if I take a value 0 to n, this is what the repeated summation we are doing. Sorry, 1 to n. 1 to n, let's chop into m part. M for metro. M for metro. N for number. So I have in repeated summation, I have I equal to 1 to n. X is 1, x is n. I chop into m part. M for metro. M part. Where m tends to infinity or whatsoever. I don't care. But it will be very high number. Where what is the gap, what is the width of one section here? That will be n minus 1, n minus 1, or if I divide n minus 1, 1 by n minus 1, that is the width of, I'm sorry, okay, the distance here is 1 to n. That if I chop into m part, then each part width will be n minus 1 by m. Makes sense? Okay, if m tends to infinity, then each section will, the width will be very small. Consider there is a function called gx, that is the height. Gx into delta x will give the area of this small strip. If I add all this area, it will give gx dx whatsoever. Concept is I have to find function called gx, and if I integrate that function, if this is fx, that is 1 by x. Consider this is gx. If I get the area underneath this gx, then it should give the exactly same value what I am getting from I equal to 1 to n. So here, like integration x equal to 1 to n fx dx should be same as summation I equal to 1 to n fx. Okay, if I'm able to find successfully gx, then I can solve this equation. What are the ways to find gx? That is the coming under question. One way that we are prescribing here, take any point x here on x-axis, take any point x here. Then at this x, what is fx? This is fx, that is 1 by x. What is the area of the fx? What is the area of the fx when there is a gap of 1? Because we see that we have divided this x-axis into many parts where gap is 1. Summation I equal to 1 to n, then it is fx summation I equal to 1 to n. There is a sigma sign I bottom, I equal to 1, and numerator is n, and then 1 by I or 1 by x, where x jumps 1, 1, 1, 1 by 1. If I take at any x, what is the height? Fx, that is 1 by x. If I multiply by 1, what is the area between another height? There are bars. There is a vertical height on x-axis. First height is 1. Second is 1 by 2. Third is 1 by 3. Fourth is 1 by 4. What is gap between these two bars? 1. Gap is 1. If I consider this as not the summation of the height, summation of the area strip, then this area is height into 1. Same. Okay, this area, if I take at any x, what is the area strip? The area strip is area strip is height, that is fx into 1. This area strip should be same as if I take any function gx, and if I calculate the area strip of this gx at any point x and x plus 1. If I take this area strip, this should be exactly same as I am getting in fx, x to x plus 1, same. If it is same, then we will get the gx. This is what analogy we were showing. Anyway, now we have fx equal to integration. Now what next we have? We have fx equal to integration x equal to x plus 1 dx dx. So both should be same. Fx should be fx, that is 1 by x. Fx should be equal to integration x equal to x plus 1 gx dx. That is the area of a strip in gx function from x to x plus 1. One gap will be there. And what is the area? That area should be same as for fx function, initial function, repeated summation from x to x plus 1. And that area is fx only, because we are taking rectangular region in the repeated summation. where here there is no rectangular region, it is little different. Anyway, that fashion. Now to calculate that, let's consider that how we proceeded in that fashion. One idea. What is the solution? That is fx equal to integration x equal to x plus 1 gx dx. I have to find gx, so that gx dx will come to integration. Consider gx dx comes to hx, then hx plus 1 minus hx should be same as fx. Makes sense? Okay. Anyway, one concept what we proceeded into is that since gx equal to integration, sorry, fx equal to integration gx dx, gx is equal to differentiation of fx. Fx equal to gx dx, gx equal to fx by dx. In that sense, it is minus 1 by x square. Okay, let's try it. Now integration x equal to x plus 1 minus 1 by x square dx. This is what we started with. If I do integration, it will come as fx only, 1 by x. Then x to x plus, if I substitute, it become 1 by x plus 1 minus 1 by x. It will become minus 1 by x into x plus 1. Result should have been 1 by x, but result is coming as minus 1 by, I'm sorry, 1 by x into minus 1 by x plus 1. Extra I am getting minus 1 by x plus 1. If this extra would have been a constant number, please watch our previous video. I strongly recommend it. So if extra comes as a constant number, here extra is coming as variable in x only. If it was a constant number, extra was a constant. Now we have what we have. We have gx, gx equal to gx equal to gx equal to minus, I'm sorry, 1 by x into minus 1 by 1 plus x. Gx is 1 by x. So whatever fundamental we used, we got the result, that is 1 by x. Extra thing that came as minus 1 by 1 plus x. If this extra thing would have been a constant, then we have just settled down the constant. That's it. Or whatever we are getting, the result, we have to just multiply the constant. But extra thing we are getting is a variable. Anyway, we will settle it down by multiplying this opposite of this variable to the gx. Gx I have considered a differentiation of fx, that is minus x square. Minus 1 by x square into x plus, now if I, what we are getting extra, what we are getting is minus 1 by 1 plus x. Okay, if I miss, this is the extra I am getting. This should have been other way. If I revert it and multiply, then I will not get this. That is the concept. If I multiply something, I get alpha, that is unwanted. Then at the beginning, I have to divide by alpha, so that is alpha will disappear from the result. Okay, in that fashion, we will try again now the kind of settling it down. So we will revert it and settle it there. This is the point where someone has to put his brain. Can we revert directly like this, or we do some manipulation out here? If I put revert and put there, now gx, which was minus 1 by x square, it becomes minus 1 by x square into 1 plus x by minus 1. It becomes 1 plus x by x square. It becomes 1 by x plus 1 by, I'm sorry, it becomes 1 by x square plus 1 by x. 1 by x plus 1 by x square dx. Now x is x to x plus 1. Now concept is this should become 1 by x or near to it. Okay, to get the near to it or whatsoever, now we have integration of 1 by x plus 1 by x square. It will become natural log of x, and then integration of 1 plus 1 by x square, and it will become minus 1 by x. So net result coming is ln of net result that is arriving here. Then what is fx? Fx is the, what is the fx? It should have been 1 by x to have the exact result, so that we can proceed with our gx to calculate the fundamental concept. So if this is the near result, what is near result? Near result is ln of x minus 1 by x. If I proceed with this gx, what is your gx? Gx is 1 plus x by x square. This is the gx we have taken. If I take this gx, then integration comes as logarithmic natural log of x minus 1 by x. If I put now x to x plus 1, because that is the actual result. If I put x to x plus 1, it will come as ln x plus 1 minus 1 by x minus ln x plus 1 by, I'm sorry, it will come ln x plus 1 minus 1 by x plus 1 minus ln x plus minus ln x plus, and then it will come as 1 by x. So it came as ln x plus 1 minus ln x, and it came as 1 by x, 1 by x minus plus 1 by x minus 1 by x plus 1. It came like this. Now see how much it is different from 1 by x. If someone is able to trace out how much it is different from 1 by x, whatever different it is from 1 by x, revert it and place in gx again and do the repeated integration so that you come to a fundamental that it will be same. If it is same, then that algebraic equation, if you integrate, it will give the summation. So this one someone can try. Okay, this is the one solution we gave. Another solution we are thinking is if this is fx equal to gx dx integration from x to x plus 1. Gx dx consider it come as hx, hx, then limit is x to x plus 1, hx plus 1 minus hx. So fx equal to hx plus 1 minus hx. Let's do differentiation of both sides. Let's do differentiation. What is hx? Gx dx is hx. That I know. Let's do differentiation on both sides. If I do differentiation this side, it becomes differentiation of fx. Differentiation of fx equal to differentiation of hx plus 1 minus differentiation of hx. So what is differentiation of hx plus 1? What is hx plus 1? Integration of gx plus 1 dx or dx plus 1, which that will come as dx1. So differentiation of gx plus 1, there is no limit now. Limit is gone. So differentiation of gx plus, so differentiation of hx plus 1 or differentiation of integration of gx plus 1 will become gx plus 1. More or less it will become gx plus 1 minus gx. What I want fx equal to gx plus 1 minus gx. That is another way someone can proceed. Okay, now fx is the repeated summation function and gx is the function that we thought about the integration. So fx equal to gx plus 1 minus gx. If it satisfies, then I have found the gx. Someone has to find gx in a manner that gx plus 1 minus gx will be the solution. Okay, one thing that we have done the successfully is repeated summation of 1 by 2 to the power x. Sigma sign I equal to 0 to n. Okay, and then 1 by 2 to the power I. This will come as a fx as a function 1 by 2 to the power x or a to the power x, where a is less than 1, not 1, less than 1. So summation I equal to 0 to n a to the power x. X belongs to ith section if I divide into subsection on x axis. This is fx. Fx equal to a to the power x. Now for that we, through the first method, that repeated approximation. To repeated approximation, we found out that gx equal to ln a to the power x by a minus 1. Let's fit it here. ln l what is gx plus 1? If it is ln a, gx came as ln a, ln natural log of a by a minus 1 into a to the power x, where fx is a to the power x. Now if I put gx plus 1, it will become a to the power x plus 1 minus same thing a to the power x. If I take out the constant and a to the power x, it becomes a to the power minus 1. A to the power, it will become ln a by a minus 1. ln a minus ln a by a minus 1 into a to the power x a minus 1, a minus 1, a minus 1 got cut out, and it become ln a to the power x. Okay, this proves that gx is not ln a to gx is a to the power x. Gx is a to the power x. Hope. Little bit confused. Someone has to try in this fashion, or through repeated summation. I'll try it again. Through repeated approximation in integration. So gx we had taken differentiation of ax. Differentiation of ax is ln a to the power x. ln a a to the power x. If I take so, then ln a to the power x dx will become a to the power x by ln a. Ln a go. The integration of a to the power x is a to the power x by natural log of a. So if I have taken gx as differentiation of fx, that is natural log of a into a to the power x, this integration would become a to the power x only. Now limit x to x plus 1 will give a to the power x bracket a minus 1. Means it a minus 1 is extra here. It should have been a to the power x. Now I will make sure that in next term I will divide by a minus 1. Now initially gx was a to the power n natural log a, or now gx is a to the power n into natural log of a by a minus 1. Let's try again. If I try again, it becomes a to the integration would become a to the power x by a minus 1 from x to x plus 1. If I fit it, it will become a to the power x. This is what the desired one. Someone can think whatever we started another discussion that fx equal to integration of gx dx. Consider integration of gx dx become hx. Now if I set the limit, then it will become hx plus 1 minus hx. Now, if I derive both sides, then if I do the derivation both sides, the first side becomes derivation of a to the power x, derivation of fx, that will become ln, it will become ln a to the power x. Right side it will become derivation of hx plus 1 minus derivation of hx, that will become derivation of hx plus 1. Hx plus 1 is integration of gx plus 1 dx, and hx is integration of gx dx. Differentiation will give gx plus 1 minus gx. Okay, and this side we have ln a to the power x. We had taken gx as ln a to the power x by a minus 1 a to the power x. That is the net solution. Come, let's fit it here. If I fit it here, it becomes ln a by a minus 1 into a to the power x plus 1 minus a to the power x. Okay, it will exactly become ln a to the power x. This is what the left side is. Okay, so this also holds true, this fundamental. Someone can proceed in this direction also. That how differentiation of fx will be same as gx plus 1 minus gx. Makes sense? Someone can try coming with a gx function whose x plus 1 value minus x value will be same as differentiation of fx. If there is no limit with it now. There is no fundamental of limit. Limit fundamental is gone. Now, if someone finds it, then someone can go more derivation, more integration, whatever. Someone find area vector, area algebra equation, whatsoever. Anyway, then we will proceed in the another problem. What is another problem? We have talked it. Consider that there is a community. There is a community, and in community there are n number of people. There is a community and there are n number of people. In n number of people, x number of people have disease. Unfortunately, in a community, there are n number of people, and x number of people have disease. We expect that x is 0, but this is how it is. X is non-zero, and x number of people have disease. Okay, now I now I go and check. Okay, I go and check people by people. If people now I have a currency. I have given this example. So I have a currency in my pocket, and currency amount is C. Currency amount is C. If I find a person as a diseased person, my currency becomes half. Makes sense? If I ask, if I take n number of people into medical test, if one by one person is coming out of the medical test, I am asking you are positive or negative. If he is found positive of the disease, then my currency comes to half whatever it is right now. If it is C, then it becomes C by 2. If it is C by 2, it becomes C by 4. If it is C by 4, it becomes C by 8. Make sense? Now, if one person comes out of the hospital after testing for the disease, out of n number of people, one person is, I know X number of people are, what is X, no one knows. Okay, any. Now, one person comes out, then one person, what is X? No one knows. X by N, I can say it is Q. Q is the probability that a person is diseased or not. Makes sense. Now, one person is coming out and I'm asking you are diseased or not. He is saying yes. My money becomes half in my pocket due to some magic. If I'm asking a person you're diseased or not, he's saying no, I'm hale and healthy. Then money becomes double, whatever it is right now. It becomes double. More and more people are saying I'm healthy, healthy, healthy. Money keeps becoming double, 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 double. Then one person comes, I am sick. Then money becomes half at whatever there. Now tell me that on an average, I try many times. All n number of people I try and see my money amount, money amount. I go to another community. Just think that I go to another community of n number of people and there x number of people are diseased. I try the same thing. I go to another community and try again same thing. I go to another. What is the average money I have in my pocket? That is the question. What is the average money in my pocket? After so many trials, what is the average money I can expect in my pocket? So this is, we will solve it through the breaking into n part, solving for each part and coming to the result. We will see it. Okay, solution what we will provide, generally it is available, but probably we will describe in different way. We'll try to come to something different also. So that it will be easy for the people. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone.